Well, hello, Year 7. Our first unit we're going to study is really about how we do science. So what is this thing we call science and how do we go about doing it? So I'm going to quickly step you through what we're going to cover so you can come back to it and refer to it when you need to. So first of all, what is science? Well, we're going to do a little bit of a task in class, so I won't give that too much away. And we'll share our thoughts in class on that one. You got a bit of homework there, which we'll come back to. So, what is science? The word actually comes from Latin, and it sort of means knowledge. One of them, scientia. So, we tend to think of, in the modern world, as science as being a systematic way we go about understanding our environment, so to gain knowledge about our environment. And that exists in, well, science exists as sort of four main disciplines: biology, chemistry, earth science, and physics. So physics and chemistry are often called the physical sciences. They're sort of the core, pure sciences. We're looking in physics at the study of energy itself and how that impacts on matter. Chemists look at matter, the idea of how the things we are, the air we breathe, the water we drink, who we are made of, this desk we're sitting at and things. And then in biology and earth sciences, it's more about understand what's happening in those real world settings through chemistry and physics. So in some ways the biology and earth sciences can be a bit harder. We have to know a bit more. Although physics and chemistry are difficult enough on their own. But we're going to break all that down for you and make it enjoyable, I hope. So I'm going to skip across the little work tasks. So I'm just sort of backgrounding some of this theory. We'll come back to that too. But obviously we're going to use our Bunsen burner at some stage. So, bit of safety. Science classroom is one of the most dangerous in the school. And it really is my responsibility to make sure that everyone in the classroom is safe, and we leave the classroom in a safe condition. So I like to say, no one leaves my room with bits missing or bits added. You're still intact. And so is the classroom. And that requires us all to behave in a very respectful manner towards each other, and towards me, and towards the classroom and all the materials in the classroom. And if we behave respectfully throughout the year, then we'll have a great time. And those who can't quite cope with behaving respectfully will find that I get a bit grumpy, and we find ways of removing them from activities and things that might endanger the rest of us. It might be me removing you from the room, but we're not going to do that, are we? So, what does science do? Well, science is really based on observation. So scientists are really good at observing stuff. They see things happening. And they think about, well, why? Why is that happening? And then they make up these hypotheses to explain what happened. And they test it. So observation skills are really, really important. And this guy that I'm sort of on top of at the moment, sorry about that, Michael. He's underneath my little image there. A guy called Michael Faraday was a chemist physicist of the 18th century in England, and he had this famous experiment called the candle experiment, which we go out try and do too. And he used all his senses, we're not going to use taste, to record as many different things about that lit candle as he could. And he apparently made 53 quite separate observations of a lit candle. We won't get 53 because I'm not going to let you use your tongue for very good reasons. We don't tend to taste things in a science classroom, just for your safety. Scientists also therefore need to be really good at measuring, and measuring carefully and accurately. So science and technology work quite hand in hand in creating machines that allow us to make measurements as accurately as we possibly can. So obviously rulers and balancers to weigh things, and measuring cylinders to measure amounts of liquid, and thermometers for temperature, and stopwatches for time, all those sort of things are things we use to make measurements, and we'll do a fair bit of measuring this year. Then we have to record it, and we need to be really careful with our observations. So we tend to collect two lots of data. We tend to collect things that are measurements, and we can put those into a table like I've done here. So I've got a table of temperature and two different flasks. They both started at 12 degrees Celsius, but for some reason flask A has become much hotter than flask B. And then those tables of information are turned into graphs, and graphs are basically a picture. So that picture quickly tells us that something's going on here. We've got the same starting point, but quite different endpoints. What has happened across these 3 minutes? And we may have seen some sort of chemical reaction in flask A that's caused a lot of heat, which didn't happen in flask B, and flask B's may just heat it up because the room's a bit warm. We don't know. We don't know where that data came from, it's made it up. But we'll use data. But we can also make observations that we can just write down. And often if we're out in the field, we collect poo samples, and we recognise that certain different shaped poos come from different animals, and that tells us that those animals have been there. So we might record those. We might count how many if we want some data, but we're just recording the fact that it happened. And so often we get observational data as well. That's not measurement. We clearly use lots and lots of equipment in the science laboratory. You don't have to recognise and name all of it straight away, but we will use a lot of it during the year, and you'll get to use many different things and learn their names. And across the years, you'll slowly get to remember it all. Fortunately, the cupboards tend to be labelled, and I'll remind you of things, and you'll slowly get the hang of it. But we've got a little activity too that will allow us to sort of meet the main ones and get to know them. And then we need to work out how to do an experiment. You guys are going to do your own experiments. So the experimental design is based on this idea of the scientific method. I've made careful observations. That's led me to a hypothesis, and I want to test it. So I need to work out a system where I can collect data by making accurate measurements that test my theory, and then analyse that data to explain what I've found. So we're going to put you through this process, and you're going to do your own experiment to finish off the term. So you need a hypothesis. That hypothesis needs to be based on an observation. The sky is blue when I wake up in the morning. Maybe the fairies painted every day. It's a theory. Might be a bit hard to prove. It's a theory. And also we need to do a bit of research. So I've got these observations. What do people already know that can help me explain my observation? Oops, I have to pause for a minute. Where was I? Oh, yes. So you need a hypothesis based on your observations and some background research to find out what we already know. From that, you might develop an aim, and that aim could be to test how much water a plant needs to grow successfully. Not a great aim, I just made that one up. But an aim of that nature, which gives you a structure to then develop your method. And the method is really important. It's the method which allows people to test whether or not your work is any good. So, it needs to be a step-by-step sort of recipe of what you're doing. It needs to be quite detailed so people can repeat precisely what you've done. We need to talk about variables. We have things called independent variables, dependent variables, and controlled variables. And we need to test our independent variable. So it's the thing we allow to change. The dependent variable is the thing we're going to measure to see whether that change has caused anything. And then everything else we try and control. So if I was growing some plants to test the water theory, I might have 5 plots with plants in them. They'd be exactly the same plant. As much as possible, they'd be exactly the same size, some number of leaves and stems. So, as clear as much as possible, they'd be identical plants. And then in identical soil of the same size pot, and maybe over 2 weeks I give them exactly the same amount of water each day. Over 2 weeks I water them each day, and they get different amounts of water. So my independent variable is this amount of water they're getting. And I'm hoping that I will see a change in growth that would prove my aim. Then you're going to need to list the equipment. What do I need to carry out my experiment? So pots and plants and dirt and water. I need to think about safety. I need to do a risk assessment. I'll talk you through risk assessments in class. But what risks are possible with my experiment? Is there glass that could be broken? Is there heat? Have we got Bunsen burns that could burn somebody? Are there chemicals? Things that we need to be very careful about to make sure you are safe and everyone else in the room is safe as well. And then we collect our data. We collect objective data. These are things that we can measure with our machines, those measurements with thermometers and things. And our subjective data. What do we see? I'm looking at these plants that are growing, and some are going a bit yellow. Now, I can't really measure how yellow, but I can describe that. So these are subjective things that tell me that there's something going on. And I'll just sort of write those notes down. And then we need to discuss and make some conclusions. What does my data tell me? Was I right? Was my hypothesis and my aim correct? Why? Why not? What does my data tell me about that? Did I make errors I could do better next time? So I need to fess up to those. Yeah, I forgot to water 2 days in a row, and one day I gave one plant more what it's meant to have, so it's not quite worked. So they're little things you can fix. And often you find other stuff. What else did you learn by doing the experiment? So you're going to actually design and carry out your own experiment. And we'll step you through the process and write how to write a report. And those that are particularly good will enter in the Science Talent Search. And if you win good prizes in the Science Talent Search, you automatically go into the BHP Billiton Science Awards. And they have big money prizes. And you get your face splashed across the paper and that sort of stuff. And social media. So that's our first unit of work in a nutshell. There's a lot to be done, and we'll keep us busy. So I'll see you in class, and we'll enjoy ourselves. See you soon.